Okay, so now I'm going to do an example of how I might get from a video where I recorded data to the actual data collection. And so what I did was I set up my marble on a ramp, and I put my meter stick directly next to my marble's path so I could see at any moment how far had it gone. I was sure to line up the beginning with 0 centimeters. And then Windows Video Player, the thing I'm using to watch this video, will only show me every second in the time. It won't show me anything more specific than 1 second, 2 seconds, 3 seconds. And I need more specific time than that. So I set up a stopwatch on my computer behind my ramp, and then I would use my phone to film it. And so now at any moment on the marble's trip down, I can see where is it and what time is it. And then that's how I'm going to record my data. So the first thing I need to do is I need to check when is the beginning of this marble's trip. I spend a lot of time in the video setting things up. I press go on the stopwatch. I put my hand on the marble. I let it go. What is the exact moment where the distance is 0, but it's been released? So let's look, keep going forward, and it's right about there. So I think that's 2.209 seconds when the distance is 0. So I'm just going to record that on my spreadsheet. And now I think a good amount of points to check would be every 0.1 seconds. So what's happening at 2.3 about? It doesn't need to be exact, so we're going to graph it and see that shape, and you're not going to be able to get an exact amount of time due to the fact that your phone camera doesn't film every single moment. It sort of takes when we're looking at it in such slow motion, we're missing some pieces, but that's fine as long as we make sure that the time and distance are connecting. We're going to just try to get as close together as possible. So 2.209. Now let's go for 2.308. It's at just about 0.75 centimeters, just below 1. So 2.308. It's at 0.75, and I'm just looking at the middle of that marble there and what distance is it next to. Now I'm going to pull it across, try to get 2.40 something, 2.383, 2.442. Let's take 2.442. Remember, it doesn't matter the difference between the two times as long as I'm making sure that my time and distance across are at the same moment. My graph is going to be able to show me what's happening. So 2.442, and the distance there is about 2.5 centimeters. What about 2.5 seconds? 2.500, and it's at just about 3.5. So 2.500, and it's at 3.5 centimeters. Let's keep going to 2.615 sounds good. 2.615, and the distance there is about 5.5. Great. Okay, now what about 2.7? 2.732. I'm happy with that. 2.732. The distance is going to be, that looks like it's just 9 centimeters. 2.85 sounds good. The distance is 12 centimeters. 2.85, the distance is 12 centimeters. Moving on for 2.907, the distance is going to be 15.75. Great. Now 3.023, great. 3.023, the distance is going to be 19.5. And you can see how even in those little segments, the distance it's traveling is increasing. It's traveling faster as time goes on. That's 3.0. 3.14 is at 24.5. Is at 24.5. 3.2 3.256. Yeah, sure. 3.256 is at 31. Okay, 3.314. 3.314 looks like it's at 33. Great. 3.429 is at 41. Great. And then my last one here, it's at 43 centimeters at 3. Oh, let me go back. I think it was just switching there. I'm going to stop at 3.429. That is fine. So I've got my data there. And now I'm going to do insert chart. And there we go. You can see it's curving up like that. It's that's not a linear thing. That is definitely got a nice curve. And so we'll look into that more. But we've definitely got a curve there. So that's really good to see. That's that same thing that we had in the gizmos. But we made that one ourselves. So great.